Hello everyone and welcome back to Treesearch Industrial Postdoc Program. And what's the name of the next STEAM, you wonder? It's Lignocellulosic Energy Applications, so most of you were right. All right, let me just see if I have everyone with me.
Hello everyone, this is Shahrzad, postdoc from Mid-Sweden University. Me and Martin from Neste are going to present a research with the title of Paper-Based Aluminium-Ion Battery. The agenda will be in three parts. In the first part, I will start with the background about aluminium-ion battery. Then I will look at the challenges in this research, and next I will mention the scientific objects. The aluminium-ion batteries are the most popular energy storage system, and nowadays a rapid growth in energy storage technology is happening. So this has highlighted the drawbacks of lithium-ion battery, such as limited sources of lithium, which is around 0.0065%, flammability, poisoning, and volatile electrolyte. All these together are against sustainability and green energy demands, and this urges to find alternative for lithium-ion battery. In the other words, the components in a new battery system like anode, separator, electrolyte, and the cathode should fulfill some requirements such as high safety and environmentally friendly, low price and abundant material, high energy density, high power density, and the long cycle life. In the next slide, the graph showing capacity and Earth's cross abundance of some elements which can be used in different kind of battery system like lithium, sodium, magnesium, aluminum, and other elements. The blue mark is showing the volumetric capacity. The red one is related to the gravimetric capacity, and the green one is showing the Earth's cross abundance of the elements. We know that aluminum is the third abundant material in the Earth, and the abundance of aluminum is about 8.2%, which is much higher than lithium. And the other thing that is really important in this graph is the volumetric capacity of aluminum, which is around 8,000 amps hour per cubic centimeter, which is much higher than other elements. It can be said that using aluminum as an electrode for energy storage systems has some advantages, like giving multivalent ions transfer of aluminum 3+, high theoretical specific capacity, which is around 8,000 and is almost 4 times higher than lithium. And aluminum is a really abundant element compared to lithium. It is low cost with developed recycling process, and it is high safety and easy handling in ambient environment. And all these advantages propose aluminum as a promising alternative for post-lithium-ion battery. The main electrode material that is using in this kind of battery is our carbonate material, which among carbonate material, graphitic material took more attention due to their high electrical conductivity and low cost. And the common electrolyte which is using in this aluminum battery is aluminum chloride with 1-ethyl-methyl imidazolium chloride. And when you use this electrolyte in the system beside aluminum 3+, you can see that we have other forms of ions like aluminum Cl4 and Al2Cl7, which can intercalate between cathode and anode. We have various challenges in this research. The capacity of graphitic material is low. And here in this graph, you can see different classes of carbonate material. And the maximum capacity of this material is so far about 160 milliamps hour per gram, which is low. And the other challenge is that the ionic electrolyte in this kind of battery system is really expensive, and it is preferred to replace the ionic electrolyte with the aqueous one. But the problem that will happen here is a corrosion problem that appears in aluminum side. And the other challenge is low cost and scalability that are technical challenges in this research. To solve the first problem with low capacity, it is preferred to design a better graphene composite to have more efficient intercalation than currently exists. And to solve the corrosion problem, a new electrolyte systems needed to be designed and optimized. And scalability is a technical challenge that can be addressed through developing a new concept of salt-carrying paper-based separator, coated graphene graphite electrodes, and using aluminum foil. And these all together provide low-cost alternative for us. So now it's Martin's turn. So I hand over to Martin.
Thank you, Shashrad.
Thank you. So.
Yes, hello everybody also from my side. So my name is Martin Häggblom and I work as a development manager in Neste Innovation. I want to show you 3 slides. First slide, which we are now looking on, is a bit background, who is Neste, and following I will show why we are involved in this project together with Mid-Sweden University, and last, what are the points that Neste see as important in academia and industrial collaboration. But let's start with this slide. Who is Neste? So Neste is a global forerunner in circular fuel and material solutions. And if you start on the left-hand side, we are 4,400 dedicated professionals, of which 25% is working in innovation. The middle ball regarding sustainability. In 2020, Neste placed 3rd on the global 100 list of the world's most sustainable companies. This is actually the 13th time that Neste is included on that list. And last year, our products helped reduce greenhouse gas emissions by about 10 million tons, which corresponds to over 1 million EU citizens' yearly CO2 emissions. And in 2030, we are targeting to double those figures. Here on the right-hand side, regarding our offering renewable solutions, we are offering sustainable solutions on a significant scale, and we have high ambitions. So, for example, we are a global leader in renewable diesel with some 3 million tons per year, and renewable aviation fuel we are scaling up to 1 million ton per year in 2022. And then we have ambitions to process over 1 million ton per year waste plastics by 2030. You can take next slide, Shashrad. Thank you. Yes, so Neste's ambition is to become a global leader in renewable and circular solutions. Drive and this paper-based aluminum-ion battery project links to sustainable transportation, and we are open to new initiatives in this field besides our current business activities. Paper-based aluminum-ion batteries project is further supporting our efforts in renewable materials, such as lignocellulosic-based material, which is showed here on the left-hand side regarding renewable fuels and materials. Further on, Mid-Sweden University is a renowned university in Sweden, and we are happy to collaborate with their experts. The companies and the public partners in Drive are extensive, and that's another reason why we are joining this project, and we hope to network with all the parties in the Drive project. Yes, and last slide. Thank you. So what do we see important in industry and academia collaboration? We at Neste want to be the go-to partner for ideas and proposals regarding renewable and circular solutions. So if you have a great ideas regarding a renewable and circular solution, Neste want to be the go-to partner for those discussions. We believe that all this can be done by building partnerships, innovation ecosystems, and value chains with all different kind of partners: industry, public sector, customers, university, research institutes, and so forth. So we are on to big global challenges, and we know we need to cooperate with all parties in value chains and in generating new sustainable business. Yes, that was basically it. So thank you for the time being.
Okay, thanks, Martin. As you know, there is a possibility to post the questions in the Q&A, and we will handle all the questions in the discussion that follows. The discussion starts at 2:00. So any questions you might have, just write them in the Q&A, and Anastasia, will again have a look at these things. Now it's time for the next set of speakers, which will be postdoc Gledson Simon-Doré from the Swedish University of Agricultural Sciences and industry supervisor Jörg Brischer from Holmen. Perfect.
Just why we're in this business is that green carbon is really a hot topic, and unfortunately the rocket grew a little bit, so I can see the whole screen here. Doesn't matter. We have a lot, as anybody in the pulp and paper industry, have a lot of carbonous material. In our case, here we focusing on byproducts. These stuff nobody has really an application for, and there are already now techniques to convert, by example, sludge into carbon-rich precursors. By example, sea green is doing it by hydrothermal carbonization, heating up sludges to 200 degrees, about 20 bars. HT Cycle is another company doing this. And if you look to the high-end applications for cellulosic graphite, you have all this stuff like carbon fibers, which is, by example, used for high temperature insulations, as here on the left side. So it's lots of energy in there. But if you're talking about carbon graphite from lignocellulosic stuff, we shouldn't forget one application. The next slide, please. The most pleasant one. This one, of course. Yeah.
This one?
Okay, the next. What the project is about from our side, which makes it really interesting, that we are being to find new applications for our old materials. We have byproducts which have very low value at this time. For example, sludges. We can convert it into carbonous material, and it would be really great if we can convert it further, refine it to something more high-tech. By example, this activated carbon monolites, Gledson will talk more about. We have bark with a fantastic structure already built in. The main use for bark today is just to burn it up. We should really find other applications for it. If we go the stair a little bit higher in the value, we have tannins, which already have aromatic structures. It has been mentioned. So we are halfway to graphite. And if you look to the tall oil pitch, even this only used as a fuel. It's almost hydrocarbon. It's polycyclic compounds in it. It's almost graphite. And we have even other materials we can use. And that is something Gleitsen will tell us more about now. So our purpose is for being in this is just finding new high-value applications for materials today regarded as low-value products or even as byproducts. Okay, that was my part here, Gleitsen.
Okay, thank you very much. I will just check if my slides is just go ahead. Yeah, that's great. Oh. Can you all see my slides?
Yes, we can see.
Okay, that's perfect.
Yeah.
Thank you for your introduction. So, since I cannot see who is watching this presentation right now, I would like also to thank everyone anyway. My name is Gleitsen Simões dos Reis. I've just started my postdoc here at SLU in Umeo. I'm going to present what is going to be my main project over the next 2 years. The title is Sustainable Carbon Monoliths for Energy Storage from Pulp and Paper Industrial Side Streams. My supervisor will be Professor Sylvia Larson, Professor Sylvia Larson. So the reason why this kind of waste are being considered for produce carbon electrodes is because of the composition. They have high carbon content, and this makes them suitable for preparation of carbon electrodes by pyrolysis. The application of these materials is also extremely important because it's a renewable and a low-cost source with great potential. Since many carbon electrodes are made by with transitional metal oxide and hydroxide, and also conductive polymers, that they have a very high performance energy in the storage device. The idea here is also to use this waste to replace these materials without losing these high performances. This is what we want, and we are going to fully investigate in this project. For instance, Zhang used cotton carbonized to produce carbon electrodes for battery and found very interesting results. They found that electrode possessed large surface area and high quantity of functional groups. And this provided a fast electrolyte diffusion, and therefore a highly efficient battery performance was reached. Since our project proposed to prepare the carbon electrodes for energy storage system, we are going here to present to the main device that are used. The most used device that are supercapacitor and battery. We need to highlight that for electrochemical energy storage device, they have been proven to be one of the most effective ones, technology for practical application. The main difference between both, it's highlighted in the diagram. For instance, batteries have high energy density, while capacitors have not. And on the other hand, capacitors have a high power density compared to the battery. This leads this device to different applications. For instance, battery is more suitable for mobile storage, energy storage applications, like cell phone, laptop, and supercapacitor for short-term energy storage or burst mode power delivery, like recuperation of brake energy and also starting cars, for instance. In the literature, there are many types of battery and supercapacitor configuration, but in this project, we are going to focus and explore the most used ones, that are lithium-ion battery and double-layer capacitor. The configuration, as you see, of both are very similar. Both, they have a carbon electrode inside with separator, but a supercapacitor, but they work very differently. A supercapacitor stores the energy electrostatically, which allow the capacitor to rapidly deliver and accept the charge, and there is no chemical reaction inside the device. While a battery is a device that stores chemical energy and transform and convert into electrical energy, and there is a reaction inside takes place to make the device work. Another very important characteristic that play important role in both device is the characteristics of the electrode. For instance, the high surface area, the specific surface area, of the electrode will play a very important role in the process. For instance, for supercapacitor is expected to the electrode to have a very high specific surface area, while for the battery, not really necessary. And this is very important because we will work with different kind of biomass. We will work with different pyrolysis conditions. We will get different carbon materials with different characteristics, and we can choose the right application for each one of the carbon material that we will have. As the main objective of this project is to use the forest industrial side stream as a carbon source to produce efficient activated carbon monolith electrodes for application in battery and supercapacitor. And to accomplish this main objective, we need also to go through each one of these three specific objectives. It's the preparation of the activated carbon monolith through chemical and physical activation, the preparation of the electrodes, development of procedures to prepare an efficient one, and also to fully evaluate the effect of the physical-chemical characteristics of the electrode on the electrochemical performance, like specific surface area, as I said, very important, the porosity, the size of the pores, the density of the material, the ash content, and the presence of functional groups, because these will make a huge influence in the diffusion of the electrolyte or of the electron. As the novelty of the project, we can say that there is no effort has been so reported to use activated carbon monolith from biomass, from pulp and paper industry waste as the main material for building supercapacitors and batteries. And in addition, this project will also try to provide a first comprehensive comparison about which kind of pyrolysis method and type of biomass can provide better electrodes with optimized energy storage methods. So, because we know that these characteristics these conditions and the characteristics of the electrode will play a huge influence in the electrochemical performance. This project raises two main scientific technological challenges that to successfully accomplish, we need to go through it and overcome it. That the first one should be how to design a suitable and efficient route for activated carbon preparation in view to obtain activated carbon monoliths with optimized properties. As I said, physical chemical characteristics, we need to pay attention to it. And for that, we need to, and the other one is to obtain a high quality biomass electrode for supercapacitor and lithium batteries with high energy. Just a minute. With high energy and power densities. And in this presentation, I also try to show how to I try to show about the expected achievement and impact of this research, since the current state of the art presents a large gap between our ability to produce activated carbon monoliths and link how the properties are connected with the electrochemical performances. This work will try to diminish or close this gap by specifically focusing on the minute correlation on the carbon properties just after pyrolysis and correlated with the electrochemical properties, electrochemical resultant properties. We also, one of these, to develop a novel carbon electrode from forest waste for energy storage device, and also to design a cost-effective way to fabricate a high-performance capacitor and battery cell. And here I finish what I tried what I wanted to talk about what will be my research. We didn't start yet, since I just arrived there in Sweden, so I need to make 2 weeks of quarantine. I was in France, and yes, I'm looking forward to start the experimental part, and that's it.
Okay, thank you, Gledson, and also Jörg. So let's see. Just remember, everyone who is listening, you can still post the questions to our speakers, and you can also write in the chat to us or use the tool to raise your hand. So please go ahead and add some questions. How is it looking, Anastasia? Did we have any questions for the speakers?
Hello, everyone, once again. So far, really calm. No questions. I think everyone was really listening very carefully. And in general, this topic is quite new and really evolving. So maybe we can have this discussion more like a panel discussion to both Gledson and Shahrazad. So I'm interested in discussing with you. Basically, you try to create the novel materials, novel functional materials. Have you thought about how would you proceed with doing the advanced characterization of these products?
It was for me, this question?
Yeah, from me, and just like to both to you and to Shahrazad.
It's not easy to hear you. Okay, can you repeat the last?
You couldn't hear me well. Can you hear me now?
No. Yes, now it's better.
It's better. Jenny, can you hear me also?
Yeah. Please.
Yes, I hear you also. It's good.
Okay. Thank you so much. So basically, you are working with fabrication of novel functional materials.
Yeah.
Right. And basically trying to understand the correlation between the product, the properties, the fabrication process is really important. Mm-hmm. And you are quite new in this field, right? So yes, maybe you can reflect a little bit about how you would like to proceed with the advanced characterization of these materials. For example, for the structural assessment or the three-dimensional studies, because it's really important also. Have you thought about it? Is it on your list?
Well, we are going to discuss actually this very in detail when I be able to start my at least to go to university and do the experimental work. But yes, we didn't talk that much yet about that, but we know exactly what we need to do. With what type of characterization that we need to do. First in the material, and for the physical part, like the carbon characteristics, like porosity, that is very important. Chemical content also is very important, like ash, like a functional group. Only after that, we will go into try to measure about the capacitance and the electrochemical characterization. First is the physical characterization, chemical, of the carbon material. Once we have the carbon material, the carbon monolith, we are going to perform the electrochemical characterization. that
Great. Thank you
we
very
are,
much.
yeah, okay. I don't know if I was clear, but
So there are some more questions, both to you and to Jörg. So a question is coming from Jakob, and he's thanking for a nice presentation, and he's saying that he doesn't have any idea in regards of biomass pyrolysis, but he hopes that this question is not really trivial. So he's wondering how much is the water content, like how significant the water content would be in the pyrolysis process, and how would you get rid of water in biomass or sludge with large cellulose fiber content?
it was for me or for you?
Both of us. I may
okay.
start up.
Yeah, okay.
Yeah, right. Obviously, usual lignocellulosics contain a lot of water and even more, a lot of oxygen. But there are already pyrolysis processes commercially available to have a precursor, at least a precursor for Gladeson's job. This is those hydrothermal carbonization we believe quite a lot in, since then you can start up with wet material. It's just the point of it, and then of course you have to proceed afterwards and given the material better or more appropriate properties, which glaciers definitely would do. And then again, since Holm would supply the precursors for this work here, we have even other materials, just like of course we have lignin, not that much at Holmen, but for example, we have tannins, which already containing aromatic structures. And if you go to this tall oil pitch, I'm hoping a lot for, then you have even 3 cyclic structures. They are diterpenes, or 3 terpenes. So that is a good point to start. So what hopefully our contribution would be to deliver precursors for Gladeson to proceed with. And that would even mean that we should remove a part, by example, of the ashes being mentioned before. Yeah.
Thank you very much. I hope we answered your question, Jakob. Then we have a couple more questions from the participants, and I was thinking if maybe I can invite you to ask these questions live. So for example, Martin, would you like to speak and ask your question directly? We cannot hear you now. I think I need to unmute you, or maybe you can unmute yourself. Yes.
Can you hear me now?
Yes.
Yeah, thank you.
Yeah.
Yeah, question to Gladeson and Jörg. Very nice presentation. How would you see your feedstock approach compared to use lignin as a feedstock, even though it's maybe you not have access to those feedstocks, but how do you see how would it compared to use lignin as a feedstock?
Well, the idea that I have is to use a lot of feedstock. It's not just because we miss in the literature this kind of situation, because sometimes what we see, they use one feedstock, they say, okay, we got very good carbon electrodes with very good electrochemical properties, but somehow I think it fails to connect and say, okay, what would be a good feedstock for carbon electrodes? Because we know for activated carbon, for instance, is the function of the carbon content. The carbon content inside of the feedstock will play an important role in the activated carbon characteristics. And this is what we are going to look at. I just arrived here, so the idea is we have I will try to understand first the feedstock of the company. I try to read many different pages. They bring different results about the composition, and this was also a point of discussion between Professor Silvia and Jorg 3 days ago, and he said that he will provide me a lot of information about about the feedstock they have, they generate, and yeah, I think it's most like the first idea is to understand the waste, how is the composition of the waste. After that, based on composition, we will also try to figure out which kind of pyrolysis, because we will try hydrothermal carbonization, microwave, and conventional pyrolysis. These will be in function of the type of the feedstock also. So this will be fully evaluated before we apply indeed the electrodes in the supercapacitor or battery. I don't know if I was clear.
Yes, basically I got the impression that you have all options open. So really nice to hear that.
Yeah, because I in my PhD I work a lot with biomass, but I worked with sewage sludge, and also some Amazon forest waste. So, but we know that each one is different. Of course, we have lignin, cellulose, but based on what kind of pyrolysis and condition we pyrolyze, we will have completely different activated carbon characteristics. And this will play an important role in the whole process. And in that we are going to want to figure out better, because we don't have this kind of information in the literature.
Thank you very much. Maybe we can continue with a couple more questions to Gleitson. So there is one question from Cornelia. Cornelia, would you like to connect and ask it yourself live? Yeah?
Yes. Hello. So I'm more interested in if it's...
I'm not here very clearly.
Yeah, okay. So is it of high importance, the mechanical properties of the electrodes you prepare combined?
Not here. Okay, sorry. Just a minute. Okay, try again.
Okay, so I've been wondering if you have, if mechanical properties are of high value for making the electrodes from biomass.
It's also one important characteristic, of course, the mechanical stability. Yeah, we need to pay attention on it also. But the main focus would be, because we are going to produce monoliths. So in this sense, the mechanical properties we need to pay attention to it. We need to provide monoliths with high mechanical stability. But the main idea is to correlate the physical-chemical characteristics with the electrochemical properties. This is what we think that it should be the most important one. But of course, we are going to pay attention to the other properties.
Do you know what is the typical strength or stiffness for the
thickness?
The strength.
Dimensions because depends on for what application. If you do for cell phone, well, it's more flat. You have like layers. If you do for car battery, it's I saw that there are some like pillars. Like it depends. I think it depends mainly of the application that you want to focus.
Yeah,
Okay.
they may jump in here. In this case, we don't have to start up at zero, since there is already numerous studies of conversion of lignocellulosic materials. By example, cellulose, lignin, even, by the way, terpenes into graphite, and that there you get at least some mechanical strengths in the, maybe in the range of glass fiber,
and also one thing that I forgot to say, that to reach a desired mechanical strength depends on the bindings that you put inside. If you want to use my idea is to not use binders, but to make more a green road, a greener road. And the idea is to put some water, because if you already have the extrusion, that's the idea. Okay, now we don't need to put the binder. We are going to use maybe only the extrusion. But this is also, it's the idea. If we see that, okay, the mechanical stability is not enough, maybe we can try to insert some kind of binder.
Okay, thank you.
Thank you very much. So how do you feel, Gleitson? Would you like to continue answering the questions, or maybe we should move to Shahrzad?
What? Oh yeah, that's okay.
That's okay. There is one more question from Atano, and I believe it's to you, because there is a question about the effect of impurities in pulp sludge on the quality of activated carbon. Would you like to comment on it?
The impurity of the waste?
Impurities in pulp sludge, are they affecting the quality of activated carbon?
Well, the impurity actually affects, as I said, because the idea is when you have, the higher is the content of the carbon, is expected to have a higher specific phase area. So if you have ash, so ash is the specific phase area is almost nothing. So it's more like the idea is to have the most purest possible. Because if you have a carbon content, it means also that you have, if you have the higher content of carbon, it means that you also will have the higher quantity of functional groups in the carbon. And this play a very important role in the process, in the flowability of the electrolyte. So that is basically this. The idea is to have the most pure possible, the purest activated carbon possible in terms of carbon content.
Thank you very much. I hope, Atana, you received the reply to your question. And I think we need to move on, but please stay with us, Gleitson, anyway, because we will go now to the questions to Shahrzad. And then we got some questions which I think are both applicable to both presenters within this panel. But now a question to Shahrzad. So basically, the work that you presented is really great, and you are focused on development of the batteries. But so basically, you're trying now to use aluminium instead of lithium. Can you please comment about what are the advantages, drawbacks? Try to compare these two materials.
Yes, that's right. Because lithium has source limited. According to aluminium, we have decided to use aluminium instead of lithium. And you know that, as I said before, aluminium is low cost and has aluminium 3+ ions that can store more energy in the battery. And the other thing is that it's not flammable, and these are the advantages of aluminium.
That's great. So I asked Gleitson this question already before, but I also would like to ask you, what are your ideas about the further characterization of the functional materials that you create? What state-of-the-art techniques would you be interested to try to employ for the in-depth analysis?
Yes, for the characterization, we have two steps. At first, we need to characterize the material with, for example, XRD to find the composition of the material. because during working the battery charge and discharge, some material would appear on the surface of the electrodes, and we need the composition of to find the composition of this material through XRD and XPS, and we can use SCM, AFM, and TM to find the morphology of this material. And the next step is characterization and measurement of the capacity and cycle life of the battery through potentiostat.
So then you can do the correlation structure properties in fabrication. Yeah.
Yes.
That's great, because we got also one more supporting question in the chat from Mehmet, and he is actually wondering if you guys have already considered using the synchrotron techniques. So in some way you already replied that you are interested in going to XRD measurements, but maybe with the help of the synchrotron you can reveal even more peculiarities. Have you thought about it?
About, pardon? Can you?
To use synchrotron.
I don't know if in the future, if we need to use the synchrotron, we can do that, but I think XRD and XPS are more helpful in our situation.
Okay. Yeah. Okay. That's great. That's great. So Mehmet, I hope you also got reply to your question. I agree with you guys, you know, like to perform advanced characterization of these samples is really not trivial. And to do the fabrication of just sample prep is really a challenging step. To move on to slightly different type of questions, we have one question from Ramiro, and he is actually asking quite industrially applicable question. So biomass is very heterogeneous. How this affects the lab to pilot experiments, how to do the, you know, like technology transfer. Lab experiments are usually done in small amounts, and probably batch to batch variation of biomass is not affecting the lab conditions significantly. But when we do the scale up, what are the challenges, what we should consider, and how to move on? So please feel free to reflect your thoughts, and not only, you know, Gleitzon and Shahrzad, but also our industrial participants.
So the question is an open question to all of them?
Yes, it's more like an open question to all the panelists. Yeah.
Yeah. Okay, I can answer this question. In our research, we have scalable facilities for producing graphene electrodes and the composite graphite. And we know that graphene is a biomass material. And the other thing is that we want to use aqueous electrolyte. It is not volatile and poisonous for nature, and it's environmental friendly. And the other thing is that aluminium is environmentally friendly too, and it can be recyclable. It's recyclable, and and the separator that we want to use in this battery is paper-based separator. And altogether are environmentally friendly, yeah.
And that's very important. So basically, that's already really great that you guys have considered how to proceed with a scale up and how to move on with it. And did, for example, the question more to Gleitzon, like batch to batch variations in the pulp. Have you thought of how to tackle this problem?
Not yet.
Not yet, but it
will
come.
Sure that but for sure that we will. It's something that we, as soon as we get the first results and so on, we will. The good thing is Jorg is a guy who likes to have a nice chat and talk and discuss a lot about this. So this is something that we will pay attention in the future for sure. Because the idea is to not only make this electrode is good for supercapacitors or battery. The idea is to make a real cell of battery and a real capacitor. We don't know if we will have enough time. 2 years, I don't know. It seems that it's too much, but it isn't. 2 years. But yeah, we will try to make it real. Let's see.
Yes.
Maybe I can continue here. So from Neste side regarding this scale up question. So yes, of course that's that's super relevant. And reflecting back a bit on the presentation that I gave on our sustainability targets to increase that from 10 million tons of decreased CO2 emissions to 2030 to 20 million tons of CO2. So we have a positive pressure on us to find solution that could decrease CO2 emissions. And with that being said, that really need to look on opportunities, because the world is full of opportunities, but we need to look on opportunities that are scalable and for people and ideas that have a clarity of thought and clarity of vision, how to bring up something from an idea to a lab to a pilot and into a commercial scale. And as Sharshad mentioned here earlier, that they have a nice facilities in the Mid Sweden University, and it all comes out to that to make a prototype that get market acceptance and also have a roadmap how to get out those solution in a commercial scale. So I think it's a topic, the scalability regarding of having a clear vision and having the right infrastructure that plays the key roles.
Thank you very much.
Yeah, thank you so much. As you can see, I've started sharing my screen. So now you have small videos of us. So as panelists, we can share our video, but it's not broadcasting out. So this is a bit of a workaround solution for this. Anastasia, was there any more questions to some of the speakers?
To the speakers from the afternoon panel, no, we don't have any more questions. There was one question that we missed for the morning session, but I'm not sure if we should take it now.
We still have a bit of time. The only thing I want to have some time for is a bit of advertisements for other conferences. So go ahead and take one more question.
Okay, so there was one question from Jakob, and it was a question to Alexander, but I'm not sure if Alexander is still connected here. But anyway, I think I can read the question and I can read the answer of Alexander. So those of you who are interested in his topic, you can see what was discussed. So basically, Jakob wanted to thank Alexander for his nice presentation. And basically, he said that the organization of suspending material around the cellulose surface is the most important insight. And then he was wondering if he understood correctly that Alexander correlates these findings to the measurements. And would you judge the rheology also impacted the effect of in molecular scales far more than the fiber orientation of polymer during outflow from two approaching fibers, fibrils? And also Jakob was wondering how Alexander thinks the fiber crowding is applicable, or is the viscosity of the polymer high enough to be not squeezed out from two approaching particles? In other words, would you assume particle-particle contact, or is the lubrication force too high? So correct me if I'm wrong, I don't think Alexander is connected anymore.
No, I'm
no?
here.
Yes.
Oh, you're here. Oh, I'm sorry. Oh, that's wonderful. So maybe you would like to reply, yeah?
Yeah, sure.
Okay, great.
It was quite a long question. I actually don't see it now.
You can go, yeah, you don't see it because it's answered, but I can split it into the smaller parts if you wish.
That's okay. Yeah. So basically, as I wrote to Jakob my answer, but what I was saying is basically that yes, indeed, at the moment we were looking mainly into the surface of cellulose and the polymer interactions, and of course we are trying to correlate the results from the molecular simulations as much as we can with the experiments, because this is important and this is the main goal of the Treesearch collaboration. So When he asked about the rheology and how far from the fiber, this is a bit tricky because it depends. I mean, we're kind of bound to the system size. So in principle, we cannot go like to simulate very, very big systems. But however, we developed recently. We developed published a model that we can, which aims actually to simulate bigger systems. But nevertheless, we need these atomistic simulations that I'm carrying out at the moment in order to proceed after that with the other model. About the viscosity and how the particles will interact with each other. Of course, we actually have planned to measure the forces between two cellulose particles interacting with each other, and based on that, we can say if of this, if the lubrication forces or the viscosity is important. But as I said, this is planned for now, and definitely we will want to look into that, the force of interaction between different particles, and we will have more insight hopefully in the future. Yes.
Thank you very much. I hope, Jakob, you received your answer. In the case, if not, please feel free to connect and to ask it.
Yes. Thank you.
Thank you very much, Alexander.
Good. Any other questions from anyone? I don't think so. Otherwise, you need to just unmute and speak. Otherwise, I would like to thank you for joining this seminar. A big thank you to all of the panelists and to Anastasia, of course, and to Per here, who's been sweating away with these technical problems. So I hope you had a nice experience in watching our live webinar. Thank you so much, and goodbye, everyone.